Geometry notes, transformations, section 6, rotations. Rotations are exactly what you would expect. A transformation that turns an image around a given point. When we are graphing, the point will always be at the origin 0, 0. Let's go ahead and say usually. If it's at the origin, it makes it much easier, but it doesn't have to be technically. We usually rotate in the same direction that we would number the quadrants, which is counterclockwise. If you are asked to rotate clockwise, find the equivalent rotation counterclockwise. We will discuss that in detail in a bit. If I take this triangle ABC and I were to rotate it 90 degrees about point B, that would give me this image, A prime, B prime, C prime. Same can be said if I were to take this pre-image here and rotate it, say this pre-image, rotate it about point A, 90 degrees, that would give me this image. If I were to take this image and rotate it about point C, 90 degrees, it would give me this image. So the point that you choose, the point that's chosen for you, is going to change how this picture is going to look. Rules for rotating about the origin. I don't know why I have this big space here. Ugh, I don't know. Let's just say figures. Rotation of 90 degrees about the origin. That's 90 degrees. We're just assuming that it's going to be the origin each time, so I didn't actually write origin here. If it's not the origin, we'll figure that out. It is interchanging x and y and changing the sign of the first one. The next one is negative x, negative y. That's a rotation about 180 degrees. The next one's y negative x. That's rotating 270 degrees about the origin. And the last one is xy, rotating 360 degrees. In each of these cases, if you take this first one, you interchange them, change the sign of the first one. If you take this one down to this, you interchange and then change the sign of the first one. From here to here, interchange and then change the sign of the first one. That needs memorized to some capacity, and that's how I memorized it. You do what you want. Please keep in mind that a 270 degrees counterclockwise is equivalent to a rotation of negative 90 degrees, which is clockwise. Negative angle is clockwise. Positive angle is counterclockwise. Rotation of 360 degrees in either direction and match each preimage onto itself. Example 1, find the coordinates of triangle ABC after rotation of 90 degrees counterclockwise about the origin. Well, let's see. See if we can use the rule that we have supposedly memorized. 90 degrees counterclockwise is supposed to take the ordered pair xy and make it negative y x. So let's see if we can do that for A prime, B prime, and C prime. So I interchange x and y, change the sign of the first. Interchange x and y, change the sign of the first. Interchange x and y, change the sign of the first. Preimage, image, preimage, image, preimage, image. So find the coordinates, we got them, and that's all because we have this memorized, hopefully. Example 2, find the coordinates of the image after the preimage DEF has a rotation of 180 counterclockwise about the origin. So here's how I would go about doing this. I write down the rule, first of all. So I don't know this rule directly, but I know 90 degrees counterclockwise is going to become a negative x, negative yx, and then 90 degrees more is going to become negative x, negative y. Now, if I know that's the rule, then this should be pretty simple. If d is negative 2, 5, I just change the signs of both of them. D prime is 2, negative 5. If e is 0, 4, I change the signs of both of them. E prime would be 0, negative 4. 0 doesn't have a sign, so you can't change it. F prime, change the signs of both. It's 4, 3. Done. Find the coordinates of this triangle after rotation of 90 degrees clockwise. Well, that's an important word, because I would rather say this is 270 degrees counterclockwise. Let me just make sure we understand. 90 degrees clockwise is the same as 270 degrees counterclockwise. Now, the reason I prefer that is because I know this rule right here, 270 degrees counterclockwise. I move this over here and change the sign, and I just move this over here. So that's going to be y, negative x. So I switch the order, and then I change the sign of whatever's on the right. So I'm just going to switch the orders first. Then I'm going to change the sign of the number on the right. Change the sign, change the sign, change the sign. This is G prime, H prime, and F prime. If you know these rules, this is pretty simple. Graph each trapezoid, or sorry, graph the trapezoid, trap, and then other things we're supposed to do. Let's graph this first. So trap, that's 0, 4. That is going to be 0 left or right, 4 units up. R is 2 units left and up 1. A is 5 units left and up 1. P is 5 units left and up 4. Get that right? I didn't. A is supposed to be left 5 and up 1. That looks better. That's not what I want. That's not what I want. I'll do it segment by segment. Could have saved a lot of time by not trying to save time. Here's the image, the pre-image, I should say, which is part A. Graph this. Believe we've done this correctly. B, graph trap prime, the image after rotation of 270 degrees. If it doesn't say, we assume that's counterclockwise, and it is because it's positive. Now, if you're using patty wax, what you do is you set your patty wax over top of this, trace over the y-axis on your patty wax, trace over the x-axis with your patty wax, trace over this figure with your patty wax, and then physically take your paper and rotate it 90, 180, well, I did that wrong. Rotate it 90, 180, 270 degrees. If you did that, you would find that the figure would have the following coordinates. Now, I don't have patty wax that I can put on top of this, so I'm just going to use the coordinate rule. Coordinate rule for 270 degrees is y and negative x, as we just use that up here. So 0, 4 becomes 4, 0. So right here is T prime. Negative 2, 1 becomes 1, 2. This would be R prime. Then we have negative 5, 1. That would be 1, positive 5. It's A prime. And then P is negative 5, 4. That's going to become 4, positive 5. Connect the segments to make the trapezoid. Now this is the same thing that you would have gotten had you used patty wax. There is no shame in using patty wax. You can use that on tests and quizzes. You have my permission. You can use it on the state test. You just put it up to your computer screen and rotate it. It's pretty awesome. All right. C, graph kite, K-I-T-E. So let's do that. See, negative 3, negative 3. It's right here. That's where we're going to put K. I is negative 1, negative 3. T is negative 1, negative 1. And E is negative 4, 0. We're supposed to rotate it 90 degrees. So what's the rule for rotating 90 degrees? This is 270 degrees. 90 degrees counterclockwise. It's going to be negative yx. And I need to write this better. It's negative yx. So if I take these ordered pairs, negative 3, negative 3, negative 1, negative 3, negative 1, negative 1, negative 4, 0. I switch their order. Then I change the sign of the first one. That's what this coordinate rule is saying. So, K prime, I prime, T prime. Whoops, messed that up. The first one was the rule. K prime, I prime, T prime, E prime. So 3, negative 3. That is K prime. Positive 3, negative 1. That's I prime. T prime is 1, negative 1. And E prime is 0, negative 4. Connect those using your company issued straight edge. And we have the image. So we did all D of those steps. An object has blank if there is a center point around which the object is rotated a certain number of degrees and the object looks the same. That's rotational symmetry. So we've discussed this before. Let's discuss it again. This has an order of 4. So the angle of rotation, the AOR, that's 90 degrees because 360 divided by 4 is 90. This has an order rotation of 2. So the angle of rotation is 360 divided by 2, which is 180. This has an order of 3. So the angle of rotation is 120 because that's 360 divided by 3. This has an order of 1, which means it has no rotational symmetry. So the angle of rotation is 360 degrees, which is 360 divided by 1. Which of the following have rotational symmetry, which have reflectional symmetry? Let's not do all of these because that will take forever. Let's name 3 and 6. So rotational symmetry, H certainly has it, I certainly has it, N certainly has it. We could name more, I guess. O, S, X, and Z. Those are all the ones, I believe. Which have 6 reflectional symmetry. There's a bunch of these. Let's just name a few. A, B, C, D, E. Let's get real crazy here. W. And my handwriting is not perfect. So mine may not look like it, but if it was written perfectly, then they would have reflectional symmetry. Some review here. I don't know if we need to do these two. Do them in the homework, but I think we're pretty good with that. I think we're pretty good with these as well. Let's review some factoring. We have a trinomial for this problem number 3, and the lead coefficient is not 1. So we need to split the middle term and factor by grouping. To determine how to split it, we need two terms that multiply to get the first term times the last term. That'd be a negative 6x squared. Same two terms add to get the middle term of negative x. What are those terms? Well, I believe that would be a negative 3x and a positive 2x. The order in which you write them here doesn't matter. Let's now factor by grouping. This first group has a GCF of x. Second group has a GCF of 1. Yes, you should write it to the front. And then each of these terms have a GCF of 2x minus 3, leaving us with another factor of x plus 1. This problem to the right of this is a difference of two squares, which factors into two binomials, x minus 1 and x plus 1. Where's the x come from? Square root of x squared. Where's the 1 come from? Square root of 1. Where's the plus and minus come from? If it's a difference of two squares, the one's always plus, the one's always minus. All right, we'll cut her off there. Please do T6 homework.